Today in Capechi's Corner, we're going to look at postulates and theorems that relate to points, lines, and planes. Now, just as a reminder, postulates are statements in geometry that we accept without proof. However, theorems are statements that if we wanted to prove, we could. These postulates are numbered. They go along with the McDougall-Littell geometry textbook. They may or may not match up with your geometry textbook depending on which one you're using. The postulate numbers don't really mean anything. It's just a way to keep track of the postulates. So postulate 5 says a line contains at least 2 points. So when we're talking about a line, we know that a line is made up of an infinite number of points, but we have to start with at least 2. The second part of that postulate, which is in red, says a plane contains at least 3 points, not all in one line. So if we want to define a specific plane, I need to have 3 points which are not in one line. And the last part of this postulate written in black says space contains at least 4 points not in one plane. So I drew a 3-dimensional object the best I could. I'm not the best drawer. That shows that if I want to define space, I have to show 4 points that are not in the same plane. The next postulate says through any 2 points, there is exactly one line. So if I start with the 2 points given and I want to draw a line, like it is in red, that's one way to draw the line. If I wanted to draw a line a different way, it's just not possible. If I have 2 points, there is only one line that will go through those 2 points. The next postulate deals with points and planes. It says through any 3 points, there is at least one plane, and through any 3 non-collinear points, there is exactly one plane. So in the first example to the left, I have 3 non-collinear points, so therefore I could only get one plane out of those. However, if I'm moving to the example to the right, if I have 3 collinear points, 3 collinear points can be found in an infinite number of planes. So that's why the postulate states through any 3 points there is at least one plane. Because if it's collinear, then I can have an infinite number of planes, but if it's non-collinear, then I do have exactly one plane in which those points are found. The next postulate says if 2 points are in a plane, then the line that contains the points is in the plane. So let's start with my 2 points are in plane M. Let's label them A and B. And if I draw a line that contains these 2 points, that line also has to be in the same plane. The next postulate deals with when 2 planes intersect. So it says when 2 planes intersect, then their intersection is a line. So I have plane M and plane P. If I want to draw where they intersect and I label that AB, they would intersect at line AB. Each plane goes on in an infinite direction in all sides, so their intersection will form a line which also goes on infinitely in either direction. So now we're moving to the theorems. Now again, this book, McDougall-Littell, numbers the theorems. So it says Theorem 1:1. That means it's the first chapter of the first theorem they're dealing with. Again, the theorem numbers don't mean anything. They're not going to match up from book to book. We don't refer to them as the numbers when we're discussing it. It's just a way to keep track. So it says if 2 lines intersect, then they intersect at exactly 1 point. So if I draw 2 lines, this is one that you did a lot in your algebra course. They will only intersect in 1 point. In the next theorem, it says through a line and a point not in the line, there is exactly one plane. So for instance, if I have a line on plane P, along with a point, we'll call that point A, that is only going to happen within one plane. I can only get the line and the point not on one line in one plane. And the last theorem says if 2 lines intersect, then exactly one plane contains the line. So again, if I have 2 lines and I want them to intersect, the only plane I can contain them in is actually the flat surface that you drew the lines in. So in this case, both of these lines intersect in plane M.